Oh, hey mathematicians, Justin here. Today we're in the shipping department of the Circleville Candy Company with a special mission to design a new package for our fancy ice cream cones. We bake the cones ourselves, then dip them in chocolate and any topping you can imagine. Once the chocolate dries, they'll be packaged up in the cone-shaped boxes that we helped design. Let's get into it. We have a variety of specialty ice cream cones. Some have chocolate and nuts on the outside, some are plain chocolate, but my favorite has sprinkles. Enough talk about treats though. Today we're focused on the packaging. We need to determine how much cardboard it'll take to cover one cone. What formula are we going to need for that? Surface area or volume? Since we'll be covering all of the outsides of the cone in cardboard, we'll need to use the surface area formula for a cone. We better figure out what that is. We'll start by looking at two cones. One is tall and thin, and the other is short and wide. Both cones have a circular base. What makes the cone thin or wide is how large that circular base is. The bigger the base, the wider the cone. The smaller the base, the thinner the cone. Both cones also have slanted sides that come to a point. The cone on the left has longer slanted sides. That's what makes it taller. The longer the sides, the taller the cone, and vice versa. If we form the net of the tall, thin cone on the left, the circular base lifts up, the slanted sides unroll, and we see the sides now form a wedge shape. It looks like a slice of pizza. Let's do the same for the other cone. To form the net of the short, wide cone, the circular base lifts up, the slanted sides unroll, and we see the sides form a different kind of wedge shape. This time, it looks like the pizza with a slice missing. Practice drawing both nets of a cone now. In order to figure out how much cardboard it'll take to package one of our ice cream cones, we need to figure out the surface area formula for a cone. Since surface area is the areas of all the faces of a 3D shape added together, we need to add the area of the base plus the area of the wedge formed by the slanted sides. The base is a circle, so what's the formula for the area of a circle? Jot it down now. The area of a circle is A equals pi r squared, so pi r squared is the first part of our formula. Now we need to figure out the area of the wedge that's formed by the curved part of the cone. What do we know about this wedge? Well, the wedge shape changes based on the size of the circular base, right? What shape is it part of? That's right, it's a piece of a circle. Since it's not a full circle, we can't use our typical formula to find its area. Instead, the area of the wedge is found by using the formula pi times r times L. The r in this formula is the radius of the circular base, but L? Where did that come from? Did you notice that there are 3 measurements labeled on the cones? There's the radius of the circular base, the height going straight up the middle, and then there's this other variable up the slanted side. The variable is written as a cursive L for lateral height. It's just cursive because a lowercase l can look like a 1, and we don't want that. Lateral means related to the side, so it's the height of the side. The height of the cone, when standing, goes from the center of the circular base to the point at the tip of the cone. The lateral height goes from the edge of the circular base to the point at the tip of the cone. Pause now to write the differences between lateral height and height. Just so you know, whenever we're calculating surface area of a cone, you will always use lateral height, not height. Back to the formula. So the formula for the surface area of a cone is A equals pi r squared plus pi rl, where r is the radius and l is the lateral height of the cone. Said in words, the formula is area equals pi times the radius raised to the second power plus pi times the radius times the lateral height. Let's practice using the formula. Find the surface area of the cone in the picture, rounded to the nearest tenth. Let's get started. In the image, underline the radius and put a box around the lateral height. You should have underlined 3 and boxed 8. Now we'll write out the formula. A equals pi r squared plus pi rl. Substitute the r with the 3 and the l with the 8, then check with me. So it's a equals pi times 3 squared plus pi times 3 times 8. Since we want our answer rounded to the nearest tenth, should we substitute 3.14 in place of pi or not? Yes, we should. So it's now a equals 3.14 times 3 squared plus 3.14 times 3 times 8. You take it from here and get the final answer. According to GEMS, you should have started with the exponent. What does 3 squared stand for? 3 times 3, which is 9. That means the next line is a equals 3.14 times 9 plus 3.14 times 3 times 8. Work the multiplication from left to right. Add the terms together, and you get the final answer, 103.6. Wait, what should our unit be? Yes, it's going to be 103.6 millimeters squared, because we found the surface area, which always has its units raised to the second power. All right, on to the next one. It says, calculate the surface area of the pictured cone in terms of pi. You get it set up. Underline the R, box the L, then write out the formula and make your substitutions. Then unpause and we'll go together from there. Your R is 9 and your L is 22. The formula is A equals pi r squared plus pi rl. So with substitutions, that makes it A equals pi times 9 squared plus pi times 9 times 22. Since we're solving in terms of pi, should we substitute 3.14 in place of pi? Not this time. Instead, we start by squaring 9. That gives us A equals pi times 81 plus pi times 9 times 22. We rearrange and put the coefficient first, then multiply what we can. 9 times 22 is 198, so rearranging that becomes A equals 81 pi plus 198 pi. Add the coefficients, and our final answer is 279 pi inches squared. I think we've practiced enough. Let's get the answer about how much cardboard it'll take to package one of these fancy ice cream cones for my boss. Before we start, should we get our answer in terms of pi or numeric units? Write down your answer and your reason. My boss is definitely going to want the answer in terms of numeric units, since cardboard isn't measured in terms of pies. Next up, we need to figure out the measurements. Here's the cone. Which measurements do we need? Write the measurements and their variables in your notes. Yes, the radius, r, is 30 millimeters. The lateral height, L, is 123 millimeters. To calculate the surface area, we don't need the other dimension, height. All right, let's get our own answers and compare once we're done. I got 14,412.6 millimeters squared. Did you? So that means our cardboard must have 14,412.6 square millimeters of material to cover the cone. Pause and compare your work to mine. Thanks again for all your help, mathematicians. Today, we learned that the net of a cylinder is made of its circular base and a wedge shape for the slanted sides, which led us to the surface area formula, A equals pi r squared plus pi rl. We used that to calculate the surface area of all sizes of cones, including our fancy ice cream cones. I'm off to report our final answer to my boss, but in the meantime, you finish your notes and get started on practice levels 1 through 3. Until next time, keep questioning, keep calculating, and remember, the height and lateral height might sound the same, but they measure different parts of a cone. See you next time. Hey.